Welcome back to another AP Calculus topic. Tonight we're going to focus on integrating rational functions whose degree of the numerator is greater than the degree of the denominator. Before we dive in, we need to get two problems under our belt. So first take a look at example A here. Our goal is this definite integral from 0 to 3 of x over x squared plus 1. So recall, the first thing you want to try is u-sub. So I'm going to start with my u as x squared plus 1, and I'm going to derive that function, and I get 2x dx. And when I solve for dx, I get du over 2x equals dx. So let's go ahead and substitute that in and see if our integration works. So I've got x over u, and in place of the dx, I'm putting in that du over 2x. Now, the reason this is going to work, you'll recall, is because you're going to eliminate one variable and you're only left with a single variable, which is the key to u-sub. So this 2 is in the denominator, so I can pull out a 1/2, the integral of du over u. Now, you'll notice that I don't have any bounds on there because I need to go and get myself some new bounds, and we call those the u-bounds. So I'm just going to plug the 0 into x in my u-sub. So 0 squared plus 1 becomes 1. And then I'll plug the 3 in as well to the x. 3 squared is 9 plus 1 is 10. And then we'll go ahead and integrate. So of course we all know the integral of du over u is the ln of u. So I have the ln of u, and I'm going to plug in 1 to 10. So I'm going to leave the 1/2 out front, and I'm going to put a nice bracket in and plug in my upper minus lower. So I get the ln of 10 minus the ln of 1. Now, if that's a short answer, yeah, that's an acceptable answer, but if it's multiple choice, you're definitely not going to see that answer. There's two ways to think about this, so let's kind of make an arrow here. The first thing we can use is log properties. Okay, so let's remind ourselves of our log properties. If I see subtraction between two logs, that means it came from division. So I could say this is 1/2 the ln of 10 divided by 1, which is really just the ln of 1/2 the ln of 10. So that's one way to think about it. The second way to think about it is, by golly, you should know what the ln of 1 is. When you graph this function ln of x, you always should be plotting that point 1, 0. So the ln of 1 truly is 0, which eliminates that from the problem, and I just get 1/2 ln of 10. Either way, we get the same answer. So before we attack our actual problem for tonight, integrating when the degree of the numerator is greater than the denominator, I want to attack this problem B here. And the reason for that is when the degree of the numerator is greater than the denominator, you've got to use long division. And I don't know when the last time some of us have done long division. So I'm going to just kind of slow down and talk through a long division problem. And one thing I want to remind you is that our terms have to go from highest degree down to lowest. And anybody that doesn't have a term gets replaced with a 0. So you'll notice when I rewrite this, it's 7x plus 7 divided by 42x squared. I'm not going to put minus 33. I'm going to put plus 0 x's and then minus 33. So it doesn't actually matter if you're missing a term over here or in here. Any place that you don't have a term, you need to put 0 whatever in its spot. So to recall long division, basically my goal is to match this first term with this first term. So I'm saying, what would I multiply 7x by so that 42x squared is my answer? Well, 7 times 6 is 42, and x times x gets me x squared. So I would say I'm first going to multiply by 6x. And then you take that 6x and you go ahead and you multiply it through. So I get 42x squared plus 42x. Okay, now, for some reason, this seems to be the toughest part for most people. Remember that when you do division, you're subtracting now. So what I do is I go through and I say, okay, I want to subtract, and I'm going to change all the signs. So I'm going to put a big negative there, and I'm going to put a big negative here. I am now subtracting. And the reason is 42 minus 42 is x squared is 0, so that's eliminated. And then I'll get negative 42x minus 33. And now you repeat the process. You match this first term to this first term. What would I multiply 7x by to get negative 42x? Well, that would be a negative 6. and then go ahead and do it. So negative 6 times these two terms gets me negative 42x minus 42. And then again, I have to go through and say subtract. Well, if I subtract a negative, that means this is now going to become positive, and this is also going to become positive. And like it's supposed to happen, those two should cancel. And negative 33 plus 42 leaves me with a remainder of 9. So how do you actually write your final answer? Well, you put down what you got. When we divided, we got 6x minus 6. But now I have a remainder, and it was positive, so I'm going to put a plus 9 over what I divided by, 7x plus 7. So just to be clear, this was what I got when I divided, and this is my remainder over my divisor, what I'm dividing by. All right, we're ready to attack our two problems tonight. Like I said, we're only going to do two. One is an indefinite integral, so let me remind you that means there are no bounds. And then the second example we'll do is a definite integral, one with bounds. So you might be thinking, wait a minute, the degree of the numerator isn't greater than the degree of the denominator. Well, like always, your goal is to try u sub. If I pick my u as x squared plus 1, I get du equals 2x dx. So du over 2x equals dx. You'll notice that's not going to cancel. This 2x is not going to cancel with the numerator. So I really have no other option. I could try to factor this, but it actually doesn't factor, and neither does the bottom. So I am stuck, and that's where greater than or equal to, I guess I should say, that long division will work. So let's go ahead and set up a long division problem. So basically, we're actually going to ignore the integral for the moment. So maybe you want to make a note to yourself, ignore the integral. All right, so we'll set up long division. So I have x squared plus 0x's plus 1 divided by x squared plus x plus 1. Okay, and you just play the matching game. How do you make this first term match to this first term? Well, they already match, so what did you multiply by? You must have multiplied by the number 1. And now take that 1 and multiply it through. So that's x squared plus 0x plus 1. So 1 times 0, of course, is 0. And again, I have to say subtract, so I'm going to go through and change all my signs. That becomes a negative, and a negative. So when I do that, that cancels. Here I'm left with x, and that cancels. So now I need to write my answer. I got a solution of 1 with a positive x left over divided by x squared plus 1. Okay, so let me say that again. This is what I got when I divided. There's my 1. I got a positive, there's my plus, positive x over what I divided by, x squared plus 1. Now, we haven't done any calculus yet. All we did was divide these two functions. Now we have to rewrite this as the integral of 1 plus the integral of x over x squared plus 1. Okay, so I'm rewriting them as two separate integrals. And now I'm going to integrate. So, of course, here I just get x. And on this side, I've got to do a u sub. U equals x squared plus 1. Du equals 2x dx, du over 2x equals dx. So notice I'm going to keep the integral because I haven't integrated yet. I have x over u, and in place of this dx, I'm putting in du over 2x. Now u sub is going to work because the x's cancel, and I'm left with that one variable. So I get x plus 1/2 the integral of du over u. So when I finally go to integrate, I get x plus 1/2 the ln of u plus c. And lastly, I'll plug that u value in, x plus 1/2 the ln of x squared plus 1 plus c. Okay? So again, if that went too fast, pause it, go back, rewind, and play it again for yourself. All right. Our final example here is going to be a definite integral. So again, that's an integral with bounds. And And again, the cleanup gets a little uglier. So my first attempt, of course, is to try u sub. If u equals x minus 1, its derivative is just dx, so clearly nothing's going to cancel. So you'll notice you kind of get stuck. That numerator is greater, the degree of the numerator is greater than the degree of the denominator. So I'm going to try the long division method. So x minus 1 divided by x cubed minus 5x squared plus 8x plus 4. So here's what I suggest. Pause it at this point, do the long division, and let's just see if we get that part the same. Okay, so again, pause it for yourself, and I'll compare with you in a moment. So I think I've got all my work on the screen here. I ended up with x squared minus 4x plus 4 and a remainder of 8. Okay, so again, pause it, kind of check my work out if you didn't get the same thing. So now, of course, I've got to rewrite my answer. So was it x squared minus 4x plus 4? And I got a positive, so I'm going to put a plus sign, 8, over I divided by x minus 1. Okay, so that's how I wrote my answer. Now, I really haven't done any calculus. We cover all this long division with remainders in Algebra 2. And then you probably reviewed it in pre-calc, but it's really an Algebra 2 topic. And now we'll go ahead and integrate. So we're going to slap an integral around the x squared minus 4x plus 4 plus the integral of 8 over x minus 1. Got my dx's. All right. So lastly, I already lost my bounds. Let me go back. It was from 3 to 4. All right, so I end up with x cubed over 3 minus 2x squared plus 4x. And I'll have to carefully plug in my 3 and my 4. Here, I have to do a u sub, so my u equals x minus 1, my du equals dx. So I'm going to keep my integral. I'm going to, well, I'll write it down first. 8 over u, and then I have du. So I can pull out that 8. Whoops. And say I get du over u. So let's see, that's going to be 8 ln. And I could leave the u and get u bounds, or I'm going to plug that original back in. What was that? X minus 1. And then I can leave the bounds from 3 to 4. All right, so I'm going to carefully plug in my 4. So 4 cubed is 64 thirds minus 4 squared is 16 times 2 is 32 plus 16. So there's my upper minus. Now I need my lower. Plug in my 3. 3 cubed is 27 divided by 3 is 9. Minus 3 squared is 9 times 2 is 18 plus 12. And then I have to add on to that. I'm going to get 8. And I'm going to kind of just bracket in what I get here. The ln of 4 minus 1 is 3 minus the ln of 2. And I'll just kind of take my time and clean this up. So what is that? 64 thirds. This is minus 16, and I'll add those together. Minus 9 minus 18 is negative 9 plus 12. So I get a 3 there. So I think this leaves me with 7 thirds. And then I have plus 8. So there's a couple ways to say it. 8 ln of 3 minus the ln of 2. Now I can't stress enough, on the AP, they just love those log properties. So again, if it's short answer, this is probably fair game, but my guess is it's a multiple choice question, and you just got to remember those log properties. When I see subtraction, I really want to rewrite that as division. So I'm getting 7 thirds, 8, and this is really the ln of 3 halves, and then of course plus c. Well, I think that does it for us tonight. We'll definitely get a lot of great review, and have a great evening.